Over the last 100 years, the modern factory has optimized itself into a blur of modern robotics. Meanwhile, the typical construction site still relies on the same basic scaffolding and human movement that builders used a century ago. Manufacturing output skyrocketed by 400% over the last century, while construction productivity dragged completely flat across the bottom of this chart. Manufacturing began to pull away in the 1920s by standardizing labor and applying mathematical efficiency to physical workspace. The construction industry of the same era relied on the brute force of individual workers wrestling a steel beam into place, rather than systemic efficiency. This created a deeply ingrained reflex. When a project falls behind schedule, the default solution is to throw more manpower at it, or demand that the crew simply works faster. Treating a complex logistical failure as a simple lack of human effort is why construction missed the Industrial Revolution. Managers often define productive labor as an individual worker's pace. They assume that if a person works faster, the project moves faster. But the physical reality of a site shatters that assumption. You can hire the most highly trained, motivated electricians available, but they cannot execute their tasks if the site environment prevents them from moving forward. Specific, cascading blockages ruin job site momentum daily. Plumbers wait on delayed drawings, uncoordinated deliveries set idle, and materials from other trades block access to installation areas. The statistical outcome of those blockages is devastating. 57% of construction activity is pure waste, leaving only 10% as actual value-added content. Manufacturing operates inversely. Factory workflows boast 62% value add, with waste reduced to a fraction of the pie. Demanding more physical sweat inside a system built on 57% waste is a mathematically unsustainable strategy. The underlying administrative culprit that allows this waste to persist is the industry's reliance on traditional, dollar-based accounting. General contractors historically measure the health of a project by comparing the estimated budget to the actual dollars spent. But dollar-based metrics are strictly lagging indicators. By the time the financial spreadsheet registers a loss, the labor cost overrun has already occurred, and the profit margin is ruined. Profit fade happens because the variables that dictate labor performance, like unpredictable weather, on-site trade interference, and blocked site access, are invisible to a purely financial spreadsheet. To fix the physical chaos on the ground, the construction industry must move away from dollar-based tracking and instead adopt an entirely different mathematical baseline. We can apply the mathematical framework that manufacturing used to achieve its growth. It relies on statistical process control, or SPC, an engineering method using data to control quality. In construction, this is standardized under ASTM E2691. The first step of this standard requires project managers to ignore the dollar cost of labor when tracking daily progress. This methodology relies on the Work Breakdown Structure, or WBS. It is a project management tool that systematically deconstructs a massive project into highly trackable micro-components. The WBS assigns an exact number of expected labor hours to every single task, creating a rigid mathematical baseline. This introduces the concept of the Work Cube. It moves project planning from the tacit knowledge hidden inside a superintendent's head to explicit, universally accessible knowledge for the entire team. This requires a rigid definition of exactly who does what, where, how, and when, leaving absolutely no room for job site guesswork. By tracking precise labor hours against a strict WBS, instead of bleeding dollars, contractors can predict and prevent delays before they materialize. Applying this strict industrial math shifts the physical geography of the construction process. Industrialization treats the construction site as a final, clean assembly point for a controlled supply chain. Time-consuming, high-skill tasks, like complex pipe welding, are moved off-site into controlled manufacturing environments to guarantee quality and speed. Digital twins and building information modeling, known as BIM, map out every inch of the assembly process. BIM is a digital representation of the physical and functional characteristics of a facility, preventing spatial conflicts before materials reach the site. Software and generative AI monitor these highly specific models to automatically alert teams to schedule variations or potential cost overruns. This orchestrated off-site approach delivers what project owners demand most: predictable schedules, predictable costs, and absolute safety. The United States construction market was once safely insulated, but it is now fully exposed to relentless global competition. Foreign competitors have already mastered these industrialized methods, and they are capturing massive domestic infrastructure projects, like supplying elements for the San Francisco Bay Bridge. Companies clinging to chaotic, dollar-based management will not survive the transition when forced to compete against this level of precision. The industry will never close the 400% productivity gap by asking its labor force to sweat harder. It will only survive by standardizing its data, moving the work off-site, and finally treating the job site with the precision of a factory floor.